Welcome to the DIY Honda Garage channel. This presentation addresses the diagnostic trouble codes P0520-17 and P0523, which indicate a high voltage condition in the engine oil pressure sensor circuit of the Honda CR-V model year 2023 and later. These codes are critical as they signal that the output voltage from the engine oil pressure sensor exceeds the specified value, prompting the powertrain control module, PCM, to record an abnormality. The engine oil pressure sensor plays a vital role in monitoring the oil pressure within the engine, which is essential for maintaining optimal engine performance and preventing possible damage. If the sensor's readings are incorrect, the PCM may trigger these error codes to alert the driver or technician of an underlying issue. Understanding how these components interact is crucial for accurate diagnosis and restoration of proper function. In this guide, we will delve into the components, possible causes of the error, symptoms of the issues, and detailed troubleshooting steps to effectively resolve the problem. The engine oil pressure sensor is integral to a vehicle's lubrication system, providing critical information about the oil pressure to the PCM. This sensor is typically located near the oil filter, where it can accurately gauge the pressure of the oil circulating through the engine. Its primary role is to monitor oil pressure levels, ensuring they are within specified thresholds necessary for optimal engine operation. If the engine oil pressure sensor detects pressure outside the normal range, it sends voltage signals to the PCM. When this output voltage exceeds a specific value, it triggers diagnostic trouble codes P0520-17 and P0523, indicating a potential issue. Such failures might compromise engine performance and longevity if not addressed promptly. As we explore this further, we'll inspect how the sensor's readings connect to vehicle operation. Multiple factors can lead to the occurrence of DTCs P0520-17 and P0523. One primary culprit is a faulty engine oil pressure sensor. The sensor may fail due to wear and tear, significantly losing its ability to measure oil pressure accurately. Another possible cause includes open circuits within the wiring harness that connects the sensor to the PCM. These open circuits can prevent the proper transmission of data or power, leading to erroneous voltage readings. Additionally, the PCM itself can also be the source of the issue. If it has malfunctioned or is improperly calibrated, the readings provided to the vehicle might indicate high voltage when everything is functioning normally. Lastly, short circuits in the sensor system can drastically affect the overall function, leading to abnormal measurements as well. Each of these causes should be closely examined during troubleshooting. Symptoms associated with DTCs P0520-17 and P0523 can manifest in various ways, affecting the overall driving experience. One of the first signs drivers may notice is warning lights illuminating on the dashboard, alerting them to a potential issue with the oil pressure system. This can often lead to heightened anxiety regarding engine health. Additionally, a reduction in engine performance may occur. Drivers might experience sluggish acceleration or stalling, indicating that the engine is not receiving adequate lubrication. Consequently, there may be an increased risk of observable oil pressure issues, such as a drop in oil pressure readings on the gauge if equipped. Furthermore, abnormal sounds from the engine, like knocking or grinding, can indicate lubrication failure, alerting drivers that immediate attention is needed to prevent serious engine damage. Recognizing these symptoms early is crucial for prompt diagnosis and repair. The initial troubleshooting step for DTC P0520-17 involves turning the ignition to the on mode without starting the engine. This allows the technician to access the vehicle's data through the Honda Diagnostic System, HDS. The next fundamental task is to check the rocker arm oil pressure (EOP) sensor voltage using the HDS. It is crucial that this voltage is monitored closely. The ideal value should be less than 4.79 volts. If the reading exceeds this threshold, it confirms that the failure is replicated, affirming a significant issue with the engine oil pressure sensor or its circuitry. This step is essential as it lays the groundwork for subsequent diagnoses, allowing technicians to validate the problem and proceed with the correct testing methods. In the second step of troubleshooting DTC P0520-17, the technician is required to disconnect the engine oil pressure sensor connector, referred to as the 3P connector. After disconnecting, a jumper wire is leveraged to connect terminals number 1 and number 2 of this sensor. This process is critical as it simulates a normal operational condition while bypassing the sensor itself. Following this, the technician again accesses the Honda Diagnostic System, HDS, to check the rocker arm oil pressure, EOP sensor voltage. It is imperative that the voltage value falls below the 4.79 volt mark. If the voltage is acceptable, this indicates that the engine oil pressure sensor is likely defective, as it fails to produce accurate readings under standard conditions. Continuing with clear troubleshooting steps is vital in diagnosing the underlying issues effectively. Step 3 necessitates a thorough inspection of the wiring related to the engine oil pressure sensor, specifically the operation sensor, OPSEN, and ground SG2 wires. Prior to disconnecting the PCM, powertrain control module connector, it's essential to jump the SCS, short circuit switch line, with the HDS. This action serves to prevent damage to the system while performing the inspections. After waiting for more than a minute, technicians can then proceed to check the resistance of the OPSEN and SG2 wiring. According to the diagnostic guidelines, normal conditions require a resistance reading of less than 1 ohm. If the readings indicate resistance greater than this or fail to meet this criterion, it points toward an open circuit in the wiring, prompting further investigation into the integrity of the connections and the condition of the wiring harness itself. The final step in our troubleshooting framework focuses on inspecting the powertrain control module, PCM. At this stage, if all prior inspections have yielded normal readings, the PCM must be considered as potentially faulty. The PCM is essentially the brain of the vehicle, responsible for interpreting sensor data and making adjustments to optimize engine performance. If it shows abnormalities or provides incorrect readings, it can lead to erroneous signals being sent to other components, thus triggering DTCs P0520-17 and P0523. If any defects are confirmed within the PCM based on this inspection, replacement may be necessary. This step ensures that technicians leave no stone unturned, verifying that the PCM itself is functioning properly to avoid unnecessary replacements of other components. Upon completing the repair process for DTCs P0520-17 and P0523, it's crucial to engage in a thorough verification process. This involves confirming that all repairs have been meticulously executed, ensuring that each component checked and replaced is functioning correctly. Following this, a test drive of the Honda CR-V should be carried out to evaluate the car's overall performance under real-world conditions. During this test drive, technicians must monitor for any unusual behaviors or warning lights that were previously present. After the test drive, a subsequent diagnostic check for recurring DTCs becomes mandatory. If the same codes reappear, this indicates that the underlying issue has not been resolved, which may require revisiting some of the earlier troubleshooting steps to ensure a comprehensive understanding of the problem. Preventive maintenance plays a vital role in avoiding future issues related to DTCs P0520-17 and P0523. Regular oil changes are essential for preserving engine health and ensuring that the oil is capable of providing adequate lubrication. Additionally, routine checks of the oil pressure can help detect any abnormalities early on, enabling timely interventions before they escalate into serious problems. Moreover, consistent inspections of wiring connections related to the engine oil pressure sensor can help identify potential damage or wear before they cause failures. By implementing these preventive measures, vehicle owners can prolong the lifespan of their engine components, maintaining optimal performance while reducing the likelihood of triggering DTCs related to engine oil pressure. In conclusion, effectively diagnosing DTCs P0520-17 and P0523 is essential for maintaining the functionality of the Honda CR-V's engine. Being vigilant about monitoring engine oil pressure can significantly impact overall engine performance, preventing potential damage. The steps outlined in this guide provide a structured approach to troubleshooting these specific codes, ensuring that technicians can identify the root causes effectively. By implementing both troubleshooting and preventive measures, vehicle maintenance can be managed proactively, thereby enhancing the driving experience. Remember, addressing diagnostic trouble codes promptly not only resolves the immediate issues, but also contributes to the vehicle's long-term health and efficiency. Please like and subscribe to the channel. See you next time.